All right, do we have any questions before we get started today? Okay, I do. Where did we leave off? Was it around here? Did we do this one? Yeah? And the whole thing, who remembers what this fancy percent sign means? Remainder, right? It's what's left over as a result of doing integer division. You're doing division like you're in grade 2, right? 5 divided by 2 is 2, remainder 1. That's what that is. And of course, if the remainder is 0, that means the number is evenly divisible by 3. Cool. And we talked about this, right? The whole else situation. With a regular if I'm the code and I'm executing the code, if I'm executing code, I'm just following the code line at a time. But with the single if, I have an opportunity to make like a bit of a detour, maybe do a little something, and then return to the execution where it was, right? I just execute the code inside the if. With an else, we end up having a case where like, well, what if we want to do one thing or another thing, but never both, right? So if I'm executing the code, we can come to a situation where, well, if the condition is true, I want to do this, and if it's false, I want to do that, and then after one of those two runs, I'll carry on after. That's the whole point of the else. And then we had this example, right? And who here remembers what the issue was? It would always be D. I mean, unless it was less than 50, yeah. Then it would be F. But it was always D. And why? Well, what does the code say? If I asked 99, there's no trick here. It's just, what does the code say? 99. Is 99 greater than or equal to 90? True. Okay, so letter grade is A+. Then I ask, is 99 greater than or equal to 80? True, so it's now A. Is it greater than or equal to 70? Well, now it's a B. Greater than or equal to 60? C. Greater than or equal to 50? It's a D. And then, well, it was D, so it's not the else case, so whatever. The issue here was I had a chain of ifs, and these ifs were all independent from one another, except, I guess, the last if and the else, right? The last if and else will be one or the other. But because these were all just regular old ifs, it would execute the if or not and carry on executing immediately after the if, which would then be another if statement. So all of those were true. What we really wanted was an even like more general version of the if-else. With if-else, we're either going to do one thing or the other thing. Mutually exclusive operate like execution of code. Either that or that, never both. Really what we wanted here was the same idea, but instead of one of two things, we wanted one of 1, 2, 3, 4, 5, 6 things. We wanted only one of those ifs to run. There are a lot of ways to address this, but the easy way would be, well, let me just take this code. In fact, I think I have the code open here. Cancel. If I run this, I see, come on, run. We see D. Now the way to fix this would be to say like, okay, if that else, and then inside that else, we can go like this. But as you can see, this is going to start getting a little hairy. I mean, this idea would work, where this, otherwise do, and then another if statement. This will totally work, but we have some nice syntax, syntactic sugar, for how we can do effectively this just with prettier code, is we just say elif, which means like else if. Now if I run it, it'll always work, because with else if, those if statements are now no longer independent of one another. They're chained together. Only one will ever run. If the first one trips it, we execute it, and then we skip all the other ones and carry on immediately after the if-else chain is done. So the elif is how we make the code do one thing, or the other thing, or the other thing, or the other thing, or the other thing, but never all of them, only one, only one. People often then ask, like, well, how am I supposed to know which one to use? And the answer to that is, well, it depends on what you want to do. I can't give you a silver bullet answer because there is no such thing. It's, do you want your code to be run like exclusively? Only one? Well, then use else ifs. Do you want it to be like multiple conditions could possibly run? Well, then don't do else ifs. It really depends on what you're doing. So I can't give you an answer on, well, how do I know which one I'm supposed to do? Well, what do you want to do? It depends on what you're doing. Any questions about this else if thing? Yeah, this is explaining what's wrong with it. And then here's the solution. Letter grade, not broken. Just it's the same thing with just a bunch of elifs. There are other ways we can make it work, right? Maybe we can do like a reverse order. If we put it in a function with a return, we can make it work without else if. There's a lot of ways. But it always just kind of depends on the situation and what you want to do. You just code it the way you need it to do what you need it to do. We can have if statements inside if statements inside if statements inside if statements. There's nothing stopping us from that. I mean, if you get to a point where you've got ifs and ifs and ifs and ifs inside ifs inside ifs inside ifs, maybe you're doing something wrong in terms of the design of your code, but there's nothing wrong with that code. Chances are, if you're going really deep nesting meaning see how I have like an if statement indent and then another if statement then indent? That's like the nesting. If you're going too deep, that might not be good. There are some people that have like a rule to themselves where they never go more than 3 deep. And if they really need to, well, they come up with an alternative way of doing it just to simplify their code a little bit. Because as soon as you start going really deep, it can get kind of hard to follow, right? So look at this code. So if I gave, like this is finding the quadrant, right? You know, your Cartesian coordinates, right? Which quadrant is it in? Which way? Hold on. 1, 2, 3, 4, right? Did I do that backwards or 4? Yeah, okay. It's hard to, I had to do it backwards to myself. So which is it? Well, it depends on what value the x's and y's are. Ignore the case of 0, 0, right, where it's on the origin. Well, it checks. If x is greater than 0, well, if y is greater than 0, then it's the first. If it's not, then it's the fourth, right? Because we've already established that x is greater than 0, so it must be on the right-hand side of the Cartesian coordinates. But we could do this the same way with an and. When you nest them like this, both of these conditions have to be true in order for this print to run, right? So it's just like and. If this is true and this is true, we print that. So we could do the same thing without nesting, like this. If x is greater than 0 and y is greater than 0, well, it's the first, and so on and so on and so on. Which one's correct is, there's no right answer. It's whichever you like. If you find yourself nesting too much and you don't like it, maybe add compound. Compound meaning you've got an if that has like more than one, an if with like an and. There's 2 comparisons and an and, right? So there's 2 conditions that were checked. Maybe you can do compound ones like this instead of nesting. Or vice versa, if your compounded if statements are getting too long and complex and hard to follow, maybe break it apart and nest it. There's no right way to do it. It's just, there's wrong ways, but there's a lot of right ways, and they're all fine. Just code it the way you like. Whatever you're comfortable with, whatever makes sense to you, you do it that way. Remember, there's literally an infinite number of ways to write the code to solve a problem. And it doesn't take the problems to get overly complex. Like, don't get me wrong, when your code starts making decisions, it's a hell of a lot more complex than code that doesn't. But in this particular example, this is not overly complex. Tell me which quadrant we're in. That's not a hard problem. But even with such a simple problem like this, The variations on how we could code this up is just wild. We could code this a lot of different ways, and they're all fine. Okay, any questions about that? Everyone's fine, everyone's happy. Oh, you know what? One thing I wanted to say, because multiple people came to office hours with this question, and this will sneak up on you. Let's say I've got a cell where I have a equals 5, and then I have another cell, well, let's call it like ASD, some arbitrary variable name, and then I say, okay, if ASD equals 5, print it was 5. I'm going to hit run, and it crashes. And it says ASD is not defined. It's because I didn't run the first one. I'm looking at this, goes like, ASD is not defined. What are you talking, like literally in the cell above, I said ASD equals 5. But I never ran that code. I have to run it in order for Python to know that it exists. So if I run it first and then do this, there we go. And the reason I'm bringing this up is some people, when they were looking at the assignment and they were trying to run the load Starbucks data and they were hitting run, it was saying that like that variable Starbucks file name is not defined. And they're going, but it's right there. What's going on? It's just because you got to make sure you hit run on the cell where that variable is defined. That's why. So if you hit run and you ever see like some variable is not defined and you're looking at it, there's two things you usually need to look for. One, did you run that code? Or two, do you have a typo? And don't think that you're too good to make typos. You'll make typos. It'll happen to you. Who here has had a typo after they realized like, no, my code's right, it's right there, what's wrong? And then you're like, oh yeah, oops, I can't spell. Yeah, see, everyone does it. Get used to it. Okay. Any last questions about this so far? So let's take a moment and realize, what are we? We're in like the third week of the semester, I think. Right? It's the third week, I think. If you don't know and I don't know, whatever. We're into the semester. And raise your hand if you've never coded before, the start of this semester. Yeah. I want you to take a moment and really think about how much you've learned already. I want to be clear, computer science ain't easy. And I'm not that good of a teacher. But if you're following along so far and everything and you're happy, good job. Pat yourself on the back. I will say, I've actually been really impressed in labs. Never, since teaching at St. FX, I've never had anyone at a lab ask for more caddis problems. And multiple people asked me that so far this year, so I'm like, whoa, all right, cool. So that's a good thing. Keep up the good work, everybody. But let's take a moment and really reflect on what we've learned so far. We started with Hello World, the world's simplest little program. But we know about variables, we know about functions, we know about types. We've learned about testing. A lot of people will never learn about testing in their degree. You've learned about a lot of different types. You made clear, okay, variables and literals, comparison operators, Booleans, Boolean operators, conditionals if, right? We have a way to branch in our code, make decisions. We've learned a lot so far. There's a lot that we've covered. Whether you like it or not, you've learned a lot, assuming you've been following along. So good job. So here's what this topic's going to be. This topic is going to be, we're going to just work through a problem. And we're going to break it down and we're going to solve the problem, okay? And we're going to break down the problem and solve the problem with everything, with the various things we've learned so far. And let's just go through it. It's an exercise of writing code to solve some arbitrary problem. So what have we seen so far? Values, types, variables, print, input, functions, Booleans, logic, if, else. There's a lot we've learned, whether, like I said, whether you like it or not, you've learned a lot. But remember, and this is the common classic thing with programming, where when people ask, well, is it hard? Well, each of these things in isolation aren't too bad. A lot of people would find each of these things in isolation, they're simple. But as soon as you start to have to put these things together to solve problems, that's where the challenge comes. So even though you might find each of those things nice and easy for yourself, putting them together may not be easy, and that's normal. The difficult part is when putting these together to solve complex problems. So writing bigger programs. There's no correct way to go about, you get a problem, let's write code for it. There's no right way to do it. There's no correct way. There's a couple strategies. There's various strategies people use to cope, but there's no right way to do it. Maybe there exists such a thing, but no one knows what it is yet, that's for sure. But for now, my suggestion is going to be a bottom-up incremental approach. And here's what I mean by it. One, honestly, start with an empty function. I've got a problem, I know I'm going to want a function for it. Start with an empty function. Give it a name, a good name, a relevant name, maybe it needs parameters and whatnot. Then have it return some arbitrary constant, 0. And hit run, and make sure it does exactly what you think it should. I know that sounds stupid, it's not, that's a good idea. It's always a sanity check. Every time you do something, every time you iteratively do something, you test it again. Make sure, did it do what I thought it would do? Is it going the way I think it goes? This is a very slow and deliberate process. But often, we'll give you a working solution quicker than just going crazy and just trying to figure it out with spaghetti. Okay, run the function and verify it does what you expect. Add 1 or 2 lines of code to the function that you know is probably going to need. Hit run, make sure it gives you what you expect. Repeat this process over and over and over until you've got your working function. And then you do it for another function. And then those 2 functions work together to solve a bigger problem. You just repeat this process for your whole program. Nice and easy, nice and slow, very iterative. You test along the way. It's a hell of a lot easier to find a mistake when you write 1 or 2 lines of code, you hit run, then suddenly it stops working. I guess the issue is probably with those 2 lines of code you wrote. If you sit down and you write 50 lines of code and you hit run and it doesn't work, good luck. That's not an easy job. I don't want to do that. And that's what makes it difficult at office hours sometimes. People will come and they'll show me their 30-line function, and they're like, help me find what's wrong with it. And don't get me wrong, I'm happy to have a look. But it ain't easy to do and look at 30 lines of code to find the issue. It's easier for you if when doing it in the first place, doing this iterative testing, it'll help you find those bugs before you even need to come to me. That's not to say don't come see me when you need help. No, absolutely come to office hours. But I will struggle. Like if you think, oh, I'll show him this giant wall of code and he'll be like, there's the issue right there. That's not going to happen. My brain doesn't work like that. No one's does. The only way I'd be able to do that if you've fallen for one of the typical little mistakes that I see, right? Maybe I can have a look and be like, okay, you did that thing that 90% of the class already did, so I'm aware of it. But in general, I'm not going to be able to do it, and neither will you, and it's your own code. So take your time, iteratively. This incremental strategy is great because first of all, it's slow, it slows you down, it makes you very deliberate about what you're doing with your code, which is a good thing. Never sit down and just want to start writing code like you see in the movies. I'm a hacker, right? That doesn't happen. No one codes like that. That's a terrible misrepresentation of reality. And it sets people up for wrong expectations. You got a no, you just water. Okay, it's great because a lot of problem solving you will be doing will be incremental. Maybe it won't seem incremental, but when I give you a problem, you kind of actually have to work 2 ways, right? I give you a problem description, and maybe you need to actually break that problem down into subproblems. Then you start solving the subproblems, which then you can use to help solve the bigger problems and bigger problems and bigger problems and bigger problems as you go. That's a normal process. And it's not going to be obvious how to break down the problem to begin with. That's part of the skills that you learn as a programmer. Programming is part of programming, but same with understanding the problem, breaking the problem down, and all that. That's a big part of it as well. When you sit down and write the code, that's like the last thing you do. You need to understand what you want to do and how you're going to do it before you can start writing code. Trying to write code before you've got the other things understood, it's not going to get you anywhere, right? Like, and I know everyone in here has done that, like in lab. We all have, right? You sit down, you're like, okay, I want a solution. And you're like, I don't know. Yeah, it's normal to want to write code, but you got to make sure you understand the problem. You got to make sure you have an idea of how you're going to solve it. Then you can start writing code. Starting to write code without that, you're not going to get anywhere. Additionally, it helps you make sure everything is working along the way. Like I was saying, an iterative process, write a little code, test it, write a little code, test it. You're going to be confident and things are working correctly as you go. This isn't foolproof. It's possible that the line of code that you add wasn't the mistake, but there was a previous line of code that had a mistake that only got noticed after you added more lines of code. There's a lot of reasons something funny could happen, right? There's no guarantee here, but this is a great way to hedge against blunders like that. If everything was working and you added to, yeah, okay. At the end of the day, we still want to write tests for the completed functions. Even though you've been testing along the way, that's fine. But you're still going to want to write your assert test at the end of the day. Because just because you have a working function, make sure the tests are written for the function. The function itself will be like a functional unit of what that code is supposed to do. When you're testing along the way, you're testing the pieces of the function that make up the whole function. At the end, you want to test the whole function like holistically. And then the reason it's important, like even though like you're certain that code is right, write the tests for the whole function. Because maybe when you were writing it iteratively, you weren't really thinking about the function as a whole, and maybe you kind of missed some edge cases. This is what people will call like, there's something called like test-driven development, where before you even start writing any lines of code, you sit down, before you write any lines of code for the function you want to write, you sit down and you write all the tests first. If I know the function I want to write, if I know what it's supposed to do, then I should know, given this argument, I should get this output. Given that argument, I should get that output. I can write all those tests. And what's interesting about this strategy is by doing this, it makes you very thoughtful about the function you're about to write. It makes you consider different cases that you might miss if you just blindly start writing code. So you might find that strategy helpful. And another reason we have these tests too is just because that function is working now doesn't mean something won't happen such that it stops working in the future. If you leave those assert tests in, remember, those assert tests are quiet. They won't do anything if everything passes. But as soon as something fails, it'll crash the program. And that's a good thing. We want our programs to crash if the code is incorrect. It's better to know that there was a problem than for you to assume everything was right, but there was a problem. It's possible that code gets changed. How many of you have written a function and then, I mean, maybe not yet, but it will happen where you've written a function and you're happy with it, then you need to go back and kind of update that function a little bit. Well, what if the updates you made breaks the function? Maybe you do end up having to rewrite the tests because the functionality of that function also changed a little bit. But that code could change. So we're going to want those tests there because it makes us aware, like, okay, if I change that code and I hit run and suddenly the tests fail, well, why? Should they not have failed? Maybe they should fail now because the function does something a little bit different than it originally did. Fine, but now go update those tests. It slows you down and it helps make sure everything is working along the way, nice and good. Okay, any questions about that now? At the end of the day, there's no right way for this. There's a couple of wrong ways, but there's no right way to go do software engineering. If you somehow in the future discover the right way to do it, you're going to be a billionaire. But until someone figures that out, at this point, a lot of this is more of an art than a science. And when I say that, I mean like you kind of just have to go based on your intuition, your gut. Based on your experience, you kind of know how to approach these things. At this point, you guys haven't developed that gut yet because you're still learning this stuff. But you are developing it as you go, and that's a good thing. Remember, you're all going to suck, but I suck too. It's just we suck at different parts of it. We all are going to be wrong until we're right. Remember that. Yeah, any questions? All right, so here's a problem, car rental. Here, we're going to solve a bigger problem than what we're used to. But it's going to be very doable, at least it should be. We're just going to follow this incremental approach I was talking about. We're actually going to take it to another extreme, though. We're actually going to go beyond the incremental approach. What we're going to do is, instead of just writing a few lines of code, we're going to make each part of a function we can test easily. We're going to make each part a function that we can test very easily. So we're actually going to make our functions really nice and simple because they're going to be nice and easy to test. And if those functional units are working, then we can use them to make even more bigger functional units that will also hopefully be easy to test, and so on and so on and so on. This might feel like overkill. If you look at the code at the end of what we're going to do, and you say, oh man, I wouldn't have done it like that. He made way too many functions. That seems overkill. Yeah, maybe. Maybe it is. Maybe it's not. I don't know. But I'm going to do it the way I'm going to do it, and if you would have done it a little differently, fine. Maybe it's better, maybe it's worse. Doesn't, it's going to function the same way. There's going to be more than one possible outcomes of this that would be considered good code. So here's the problem. A car rental place needs our help. They want a program to calculate how much a customer is to be charged based on their rental agreement, age, how far they drove, and how long they had the car. Okay? That's what it's going to be. And here's the rules. We will get and record the customer's age, rental agreement classification, number of days, starting odometer reading, and ending odometer reading. And based on this information, we're going to do some calculations to tell us how much they should be charged. If the classification code is B, their rental agreement classification code is B, they are charged $20 a day, plus 30 cents for every kilometer driven. Classification code D is 50 bucks a day, and they're charged 30 cents for every kilometer driven above a 100 kilometer a day average allowance. First thing we have to do here is, oh, and here's another thing. All renters under the age of 25 are charged an additional $10 a day because apparently ageism only goes one way. You're allowed to discriminate against young people, but just not old people. Okay, right. First, let's understand the problem. Before we can start writing code, what's the problem? Well, we'll get their age. That'll be helpful for knowing if they're under 25, right? That's easy. Their rental agreement classification, well, that will dictate which calculation I use. The number of days they rent. Okay, well, that'll help us calculate the average number of kilometers they drove a day. Starting and ending odometer reading, well, that'll tell us how many kilometers they drove. So these are all pieces of information we're going to need, and that will help us solve this problem. So I think classification code B is perhaps the easier of the two to understand what's going on. It's just how many days did they have it? It should be $20 times the number of days, plus 30 cents for every kilometer driven. And we can calculate that from the difference in the odometer readings. Classification code D is a little bit hairy. It's $50 a day, plus 30 cents for every kilometer driven above 100 kilometer a day average. So I need to know how many kilometers they drove on average a day, and then any amount above 100, I apply 30 cents. I calculate the 30 cents on that and add it to the total. Little hairy, but we can do it. Are there any questions so far? All I've done so far is just talked about the problem. You may have felt that that was overkill. Maybe this was an obvious problem to you. Maybe I didn't need to talk about it. Or maybe talking about it helped you understand the problem. You're probably more normal if after one read you didn't understand what the hell was going on. Take your time and understand the problem. That's important to do. I would argue this is a simple problem, but it's not trivial. Just because it's easy doesn't mean it's like, just because it's a simple problem doesn't mean it's trivial. Something that's simple can still be difficult to do, right? So an incremental solution. All right, well, step one, read the problem. I got to read it first. Okay, well, we already read it. Step two, understand the problem. I know I just said this, but I'll say it again. I cannot emphasize this enough. This is a huge part of problem solving. It might seem obvious. If it is obvious to you, great. But every year I see people jumping to writing code for a problem they don't understand. It's natural to want to do that, but slow it down. You got to take your time, understand the problem before you try to solve it. Half of this description was I/O, right? Get their age, starting odometer, ending odometer, average or number of days, classification. That was I/O. And I/O, we're pretty good with I/O. We want to input information, it's an int, or we do input. We want to output information, we print it, right? Not too bad. We'll start there because we know how to do this, okay? I don't think we need a function for this. This could just be at like the top level of our code. We can just do some I/O. The other half of the description is just some mathematical calculation. And then step three is, well, we start chipping away at the problem. Take our time, solve one bit at a time, and next thing you know, we're done. But as I said already, this is just going to be one example of a working solution. There are a lot. The example solution I have here, you might not like. That's fine. You might like to do it another way. Good, that's awesome. So input here. I'm just going to copy this. Let's go to a new one here. Nope, not that. There. Now, obviously, this won't run because we've got an issue here. So I'll just replace that with some 0, right? What's their age? They're 10. B, 1, 0, 1. Total charge is 0. Well, why? Well, I just wrote this code. All I wanted to do is verify that the input works. If I wanted to, I could print out all these values and check if their types are correct. Maybe that's a really good thing I should do. And then I did this total charge. I set it equal to 0, but in reality, I'm going to need some calculation there, right? But for now, I'll just leave it at 0 just to make sure that this works as I expect. And based on this, I should see a 0, which is what I get printed out. The total charge is 0. There we go. Writing tests for input like this and output is very difficult to do. It's because they're called like side effects. The program's operation, it actually has to kind of like interact with like the outside world. It's got some side effects. Those types of things are difficult to test. So the easy way to do it is just print like what I have here. Unfortunately, we can't really do it with assert. We could assert the types of the things that you get, I guess, but if I hit run, 10, B, 2, 1, 3. I see 10, it's an int. B, it's a string. 2, it's an int. Float, yeah. That's what I would want. So with this, I couldn't really test it with an assert test. I just had to print it out to make sure it was giving me what I would expect it to based on the code I wrote. So this is all great, but now there's this whole total charge calculation. Well, calculating the total charge. Well, we could write a function for that. But there's some complexity here, right? Regardless of the classification code, I need to know how many days they had it. I want to know the odometer reading, like the total kilometers they drove. I might want to know the average kilometers that they drove. Yeah. So here, I'm going to start writing the calculate total charge function. But as I do it, I'm going to be aware of what I want to have. So here, calculate total charge. This function is going to need some number of parameters. I'm not 100% sure yet. I'm going to want to calculate the total charge. Set up a variable for our total charge. Calculate the number of kilometers traveled. Calculate the average kilometers. And then if rental code is B, what does it say? Base charge of $20 a day plus 30 cents for every kilometer driven. This is just taken from the description of the problem. Else, we'll just assume if it's not B, it's D. Number of kilometers above allowance. Okay, base charge is $50 a day plus 30 cents for every kilometer driven above the 100 kilometer a day allowance. And we are going to have some conditional check on their age. And at the end of the day, we're going to want to return some total charge. Obviously, this is a non-functioning function, right? I just made like a skeleton layout of what the pieces of the function I'm going to want. If I hit run on this, it's not going to work for a lot of reasons. But it just sets up, right? Sets up what we're going to need to do in terms of thinking about what we're going to need to do. It might feel silly to do it like this, but it told us something. We need to know the total kilometers driven. We need to know the average kilometers a day. We need to know the number of kilometers driven above 100 kilometers a day allowance when it's classification code D. We need to know the actual classification code, and we need to add the extra charge if they're above 25. That's all that I have in that function. All of that code I wrote there so far, I know it's not going to work. It was just to get a sense of what I need. You know what? Calculate total kilometers traveled. I can do that pretty easy. That's easy. It's the ending odometer reading minus the starting odometer reading. If I picked up the rental car and it had 100 kilometers on it, and when I returned it, it had 200 kilometers on it, how many kilometers did I drive? 100. The difference between the two. So I can do that. Let's write that function. There. It might seem silly. It's a one-line function. You're right. Maybe if you were to do this, you wouldn't even have made it a function. Okay, that's fine. But I did. Because odometer finish minus odometer start, that's probably self-descriptive enough code where someone can figure out what that's supposed to do if you just saw that line. But to me, a function called total kilometers, where I give it two odometer readings, it's a little clearer to me. Maybe you don't agree, and that's fine. I'm doing it this way. You could do it another way. But that's all I've got here. I've got my docstring, I've got my type hints, and of course I've got my assert tests. I could have wrote this assert test before writing the function. Easy peasy. But there we go. That's my total kilometers. And with this, I then know I could go here and just call this function with whatever the parameters are going to be called for the odometer start and end. And I know that's going to get me the total kilometers because I wrote that function and that's what that function does. So if I need to know the total kilometers based on the starting and ending odometer, just give it to that function. It'll do it for me. I'm happy. Yeah. Average kilometers a day. Well, in order to do this, I would need to know, well, how many kilometers did they drive and how many days were there, and then I could just do the average, total kilometers divided by the number of days. I can write another really simple function to do this calculation. Average kilometers per day. I forgot my assert tests. There, I'm happy. Again, another ultimately one line of code function, but num kilometers divided by number days, that's probably not going to confuse anybody. Someone who doesn't really know what this code is supposed to do could probably look at that and be like, well, yeah, it's like an average per day. Yeah, fine. But you know what's even clearer to me? A function name called average kilometers per day. I find that even easier. And because this is a nice function, it's easy for me to test. So after I run these tests and everything pass, I'm going to be pretty confident that this chunk of code is going to work exactly as I expect it to. Great. Well, this is great because now here, average kilometers, well, that's just going to be average kilometers per day with whatever the arguments need to be. Total kilometers, average kilometers. Look, we're already chipping away at this problem. And I know I wrote simple functions to do it, but even with these simple functions, I'm able to fill in the blanks pretty quickly and easily now. I'm doing it slow, I'm being meticulous, and that's a good and important thing. Now, this one's a little harder. How do I calculate the number of kilometers above the daily allowance? Well, here's what I could do. I'm going to have an if. If the average kilometers is above 100, give me back how much above 100 it is. So for example, if the average kilometers was 110, 110 is above 100, right? Return 110 minus 100, well, that's 10. Well, that's just how much more than 100 110 is, 10. If it's not, if the average number of kilometers is not above 100, well, then they didn't drive any number of kilometers above the average, meaning that it should just return 0. Hopefully this is clear. Is this clear to everybody? Yeah? If I drove 101, well, that's above 100. What's the difference? 1. They drove 1 kilometer above the average. If they drove 99, well, that's not above, so 0. They drove 0 above the average. Oops. There, cool. If the average kilometer travels above 100, return how much above, otherwise 0. There, I added a comment to make it even clearer for anyone who was confused. Maybe that comment was overkill, I don't know. Is that clear to everybody? Now, this function isn't a scary function, but it's definitely more complex than the previous two. The previous two were just some very basic arithmetic. Calculate the difference, calculate the average, right? Do a subtraction, do a division. This one's a little different because we actually have an if and an else. We have a decision to make. We checked, is it above 100? So when it comes to testing, I'm going to have more cases to make sure I'm aware of. And I also want to make sure I'm around edge cases too to make sure I'm not on the wrong side of 100 and some funny value doesn't get returned. So when I do 100, is 100 greater than 100? No, so it should return 0. That is like the edge case. If they drove 101, well, that's 1 above. 99, that's below. So these are all around that edge. And then if it's 200, well, I should get back 100 because 200 is 100 more than 100. right? Everyone's being really quiet, and I can't tell if that's because this is so painfully simple that you're like, yeah, come on, get on with it, or if it's because you're scared and confused. I can't tell. Raise your hand if you're scared and confused. Yeah, a little bit. Just bear with me then. We'll take our time with it. But look, I now have this. I can go back up here, and I can calculate, with whatever arguments needed, the number of kilometers above the allowance. And if that's the case, look, the total charge, yeah, maybe, it's not looking too bad. So here, I'm going to go here. Copy all this code, because now this is the final working version. But you know what? Let me not jump ahead. If it's classification code B, all I need is 20 times number of days plus 0.30 times total kilometers traveled. That's B's, right? I have all the pieces of information I need to do that calculation. Down here, total charge would be equal to $50 a day, whatever number of days. Now, mind you, I'm saying number of days. I didn't define this anywhere yet. I'm still just kind of like writing my ideas down in code, and we'll clean it up later. Number of days plus, 30 cents times, not total number of kilometers, but this one. Number of kilometers above average. Yeah. And then here, this should be easy. This should be if age is less than 25. Charge equals total charge plus 10. They just charge you an extra $10. And yeah. Now here, I'm going to go and I'm going to copy all of this. And this is a full working solution. So what did I do? Well, here, for the sake of readability, by the way, Python will be fine with this if you break down the parameter list to be on multiple lines if it was too long. This function takes 1, 2, 3, 4, 5. It has 5 parameters. Number of days, age, rental code, odometer start, odometer finish. Good, because we're definitely going to need these things for the calculation. Total charge starts at 0, great. Total kilometers traveled is, well, call the total kilometers with the starting and ending odometer readings. We know that function works, so I'm confident that total kilometers traveled is correct. Average kilometers a day, we'll give it the number of days and the total kilometers traveled. We already tested that function, so average kilometers is probably correct. If it's rental code B, it's 20 times number of days plus 30, total kilometers traveled, else 50 times number of days, 30 cents times the result of this. Maybe I should have saved this in a separate variable, but whatever. I've got a bunch of tests, that's all. All right, we'll pick up here whenever next class is.